Dear students, another lecture, chapter number 25, physics for scientists and engineers, Giancoli. Okay, now in this lesson I am going to explain the resistivity, the term resistivity. So the resistivity is basically it's a material property. Every material has its own value of resistivity. Each and every different materials have different resistivity, and this resistivity value is same for the same material. For example, uh, let me define this resistivity. So it is the resistance of 1 meter cube of a wire. 1 meter cube of a wire. Any wire that has the resistance of in the whole its length and its volume, whole resistance is basically the resistivity. Okay, so in order to find the resistivity, so first I have to explain this. For example, if we have any conductor, any material, it has length L, for example. So if we increase the length, so the resistance also becomes resistance also increases. If we increase the length, for example, this length is 2L, the resistance also becomes 2. Resistance also increases to 2 times 2R. So what does it mean? Why it is so? Because if length is increased, so that the basically resistance is offered by the charges as the charges move through. For example, if we connect with the battery, so as the charges move through this wire, so that the charges flow through this wire, and the charges has opposition. Okay, so if we increase the length, so the more opposition is offered by the atoms, because if we increase the length, so the number of atoms are increases. So what does it mean? It means the resistance is proportional to its length, number one. Number two thing is, if we increase the area, for example, if we have a for same length, for example, if we increase the area of the wire, so when we increase the area of the wire, so the resistance becomes small, because we know that for the larger area, it is very easy for charges to flow, to get to move from one end to other end. So the large area is large, so the resistance becomes small. So this can be represented by using this formula: R is inversely proportional to area A. So I repeat again, if the length increases, resistance also increases. So it means the resistance is proportional to length. Mean if we increase the length, so that the number of atoms increases, so that the resistance or opposition by the atoms must also increase. But when you increase the area, the resistance becomes small. Because why? Because if area is big, so that the charges can flow easily. It is very easy to flow the charge in the this one, as compared to the smaller area. It is very difficult to move the charges to the other end, because the smaller area, it's just like a street. If you want to pass through a street, and street is narrow, it is very difficult for you to pass through. But if the street is wide, so you can easily pass through that. Okay, so if area becomes large, so the resistance becomes small. So this fact can be written as resistance is inversely proportional to area. Now we combine these two terms, we get R is equal to L over A. R is proportional to L over A. Combining these two terms, if we combine, so we get R is proportional to L over A. So if we remove the proportionality, we introduce a constant, rho L over A. This rho is actually the resistivity. This term rho is actually the resistivity of the material. So this resistivity is the property of the material. Every material has its own resistivity. Just like silver is best conductor. Why silver is the best conductor? Because its resistivity value is small, so it offers less resistance. If you use silver, it offers less resistance, so that's why its resistance is small. So it's the best conductor. Silver is best conductor. Why? Because its resistivity mean the constant value is very, very small. I again repeat, resistivity is the constant of proportionality, the rho, that is represented by rho, and that is the one resistance of 1 meter cube of the wire. So that and the resistivity depends on the material. I mean, every material has its own resistivity. Okay, so copper has different, copper has value, gold has, aluminum has, and tungsten. This table shows the value of the resistivity for different materials. Okay, so the material that has very smaller resistivity is the best material among all these materials. Okay, now if I conclude this, what is difference between the resistance and the resistivity? So resistance is basically, resistance is the property of a physical property of a material, because the resistance is the opposition offered in the material is called the resistance. But resistivity is basically, it's a material property. Every resistivity is same for same material. If for example, if you use copper wire, so the resistivity of copper wire is same. But if you use copper wire of different lengths, for example, if you increase the length of copper wire, so the resistance is large for larger length. For example, if you use two copper wires, one is the smaller length, other one is the larger length. So the larger length has the more resistance as compared to smaller length. Similarly, the area, if you use small area, the resistance is large. If you use big area, so the resistance will be small. So that's it depends on the physical property. It depends on the resistance, depends on the length and area. But resistivity for copper is same. It's just a material property. If you use different materials have different resistivity. Okay, thank you. I hope it will work. Let me see anything. Okay, now one more thing, the resistivity, and the next one is the conductivity. Conductivity is the reciprocal of resistivity. If you took 1 over resistivity, it will give you the conductivity. Conductivity means how much material is conductive. Okay, the material whose resistivity is small, rho is small, conductivity of those materials is high, because they are inversely proportional. And the resistivity has the unit of resistivity is unit of resistivity rho, because R is equal to rho is equal to R is equal to rho L over A. So rho is equal to R A over L, so that the resistance has unit ohm, area has unit meter square, length has unit meter. So meter will be cancelled, so its unit is ohm meter. Ohm meter is the unit of resistivity rho. And the conductivity sigma has unit of 1 over ohm meter. So it's a ohm meter inverse, reciprocal of that one. Ohm meter inverse is the unit of conductivity. So the conductivity is the opposite of the resistivity. So the material whose has a smaller resistivity, it has more conductivity. So the silver is more conductive, best conductor, because it has smaller resistivity rho constant. And what is this alpha? Alpha is the thermal expansion coefficient. For different materials, how much they expand, it is determined by this constant. Okay, determined by this constant. Okay, thank you.